I guess. Some of you been to many of these before? Alexei probably recognizes better than I do the names.
Yeah, I see a lot of familiar names. So welcome, Alan. Welcome, Anton. Welcome, Artem, Ashwin, Don, Evgeny, Hert, Igor, Ilias, Joel, John, Konstantin, Kia, Nir. Welcome, Ramazan. Nice to see you again. Welcome, Sergey, Todd, Valery, Vern, Vishal. So many nice people on the webinar. Welcome, Mark, by the way.
Do we have to welcome you as well? You got to welcome. Welcome, Alexei. Okay, here's the YouTube link in case you want to watch it afterwards or share it with someone else. We'll just give a few more minutes for people to join, and then I guess we'll get going. If you have any questions, you're on YouTube, ask them in the YouTube chat, and I'm watching on there. And if you're with us on Zoom, ask them in the Zoom chat. Make sure you set it to, well, actually, you can set it to everyone, or you can set it just to us, and I will ask them when we get a little gap. Cool. So how many minutes are we? We're 2 minutes past. Maybe we'll give 1 more minute, and then we can do it.
Yeah, just 1 minute. We have a lot of features, a lot of things to tell.
You know, I actually went on holiday, so in theory, I should have given you a picture. I could have had a picture, like a background picture on one of your slides, but maybe next month.
Yeah, I prefer to take photos by myself, but I rarely have a chance to do it.
So you have to get some from the others. All right. Shall we do this then? Shall we get started?
Okay, let me find my slides. So this is ClickHouse release 24.8 LTS. LTS means long-term support. This release will receive patches, security fixes, bug fixes for at least 1 year. It is ClickHouse August release. It has a lot of interesting stuff. So let's start. We have 19 new features, 8 performance optimizations, and over 60 bug fixes. And as usual, let's start with small and nice features. And the first one is usability improvement for ClickHouse Client and ClickHouse Local. Now we have, since 24.8, multi-line mode by default. So in the previous version, if you type 2 queries and just send them with the default option like -q, it will complain that multi-statements are not allowed. And you have to provide explicitly the option multi-query, or similarly the option -n. So it distincted between single query mode and multi-query mode. But in the new version, you just provide your script, and it automatically split all the queries. It works for complex scripts with insert queries, with select queries by default without any options. So it is definitely nicer. Okay, another interesting feature is a new virtual column for table functions for external data processing, like S3 table function, Azure Blob Storage, HDFS. So for these functions that allows you to process external files, you can extract the E tag. What is E tag? It is an HTTP header used for caching purposes. And in S3, it is typically just MD5 of the content of your file. So you can take this MD5, and if it was not changed, the file is also likely to not change. And if it was changed, the file is likely to change in the content. So it is pretty nice. Maybe you will need this feature, maybe not, but now we have it. So use it if you want. And yet another feature. I know many of you waited for it for so long time, and now we have it. Support for Histyle partitioning. So what it is? Histyle partitioning is a way to place the data across different directories in a file system or in S3 or in HDFS, where you have subdirectories in the form of key equals to value. And you can have multiple such subdirectories for different partitioning by different columns. And in this example, you can see that we have a data on S3 in a certain bucket, and it is partitioned by the type column, year column, and quarter column. And the values can be specified directly in the directory structure. And in the latest release, 24.8, you can enable Hive partitioning. It is not by default, but we will probably enable it by default in the next release. And it will automatically recognize this partitioning as virtual columns. And these virtual columns will be named exactly like they are in the directory: type, year, and quarter. It will automatically infer the types, so it is pretty nice to have. In the previous version, you could use the path virtual column that will extract just all the path, and then you can parse it by regular expressions, but it was not so convenient as with the natural support. So let's take a look how it works. Let me take some examples, and I will copy paste these examples to my terminal. So let me open a server, and I will explore some data in a public bucket. This is not even my bucket. It is a bucket for UCLA open data set for network performance. First, let me analyze what it is. We have a bunch of files in subdirectories, and let me infer the types. Okay, it works, and we have these files with some columns. Everything is all right so far. Let's take a look. What are the files? In this example, I will use the path virtual column just to enumerate first path in the data. Okay, so we have 44 files. They are not as large, just millions of records each. And the path contains Hive partitioning. Let's try to get used to this Hive partitioning with a new feature. First, I will enable it. And first of all, it will not add any columns into the table schema because these columns are virtual. Virtual columns means when you do select star or when you do describe, they are not visible. But you can use them nevertheless if you type them by their name explicitly. So let's try to use these virtual columns. We have partitioning by year, so let me use this column. In this example, it is underscore year. By the way, I don't like underscore, so I asked my colleagues to remove it. And probably today in the release, we will see these virtual columns without underscore. It will be just here. But before the release, I will have to type it with underscore. And it works. Data is filtered. Everything is perfect. It works as expected. And let's try to use another example. Let's analyze their values and data types. It has to fetch data from another region. It takes some time. And the data types, first is string, actually low cardinality of string, because it has a single value for every file, so it is reasonable to have it low cardinality. And numeric columns were inferred as int 64. So let me ask you, Mark. Mark, are you excited about this particular feature?
Am I excited? Yeah, no, it's good. Yeah, I think there's a lot of data in this in this format, so this is cool.
Okay.
Does it do it for writing as well, or it's only for reading?
No, for now it is only for reading.
reading.
So please not be so excited.
Half excitement.
Yeah, take half of your usual excitement and it will be all right.
Calm it down.
Okay. The next feature is probably less exciting. It is a new function. It is named PrintF. You probably know PrintF from C or from, I don't know. Every language has PrintF. And the fact is we did not need this feature at all. We already have another function named format. It exists for many years and it works. It works like this. But in the new version, there is another function, printf, that is different slightly in the style of substitutions. I would say format is Pythonic, and printf is old school C style. And both work, and both work all right. And actually, it was added only for compatibility with Spark. If you used to use Spark, if you don't like it, if you want to use ClickHouse, but you are too lazy to rewrite your queries, now we have it for you. And yet another small feature, tags for query cache. So you know there is a query cache in ClickHouse. You can enable it by a simple setting, use query cache. And now you can have segmented query caches that are segmented by different tags. There is another setting named query cache tag. And you can provide any value, whatever you like, whatever identifier, whatever string. So the cache for this particular tag will be completely independent. And the use case is when you want to just stash some query result into the cache, but not provide it to any other queries by default. It is probably useful when query is run and then you want to like download this result again and so on. Another new feature. We have a lot of new features. The ability to control the behavior of projections during merges. So let me remind you, in ClickHouse, there is a feature named projections. In any merge tree table, you can provide a usual structure, and also you can provide a projection that looks like another table embedded into the main table. And this another table can contain a subset of columns. It can be sorted differently. It can be aggregated. So you have incremental aggregation. And these like subtables will be automatically used for query optimization. The question is what the behavior will be if your merge tree table is unusual, like replacing merge tree, aggregating merge tree. What to do when the main data is being replaced or aggregated. And projections can become just inconsistent with the main data. And in the previous versions, we did, guess what? Mark, guess what we did with projections?
Guess what you did with projections? I don't know. What did you do with projections? Something cool.
What is like the most simple and dumb way to deal with the problem?
No, I don't know. I have no idea.
Let's ask our audience. They should know.
All right.
I will give just 3 seconds.
I don't, well, you might need longer than that for them to type it. Drop them, drop and force a recalculation, recreate.
This is just too smart. What the behavior of the previous version was and still is. Okay, I will tell you. We did absolutely nothing.
Oh.
So the projections remain. It became inconsistent with the main data, and if a query was optimized with projections, these modifications like replacing or aggregating just did not affect these query results. But it is kind of okay. In the new version, it is a little bit more sophisticated. In the new version, you can control the behavior with a new setting. Deduplicate merge projection mode. It has one of 3 values like throw exception, so it will not let you create projection or use it. Drop, it will invalidate the projection when the main data is modified, and rebuild. Like the heaviest option, it will construct this projection from scratch. And you will get the consistency of projections with respect to the main table. And by the way, we already have another setting for to control this behavior with respect to lightweight deletes. Okay, what about performance improvements?
I think we did get good reply from Artem, who says use materialized views instead of projections. That's my favorite suggestion.
You know, it is also possible, but materialized view will also remain with its data. It is not affected anyhow by mutations, by background merges of the main table. So if you want to delete from the main table, you will delete just from the main table, but not from the materialized view. And it is natural. Maybe materialized views just make this behavior more like transparent, more direct.
We've got some questions from a couple of slides back. So, sorry, this is for Hive partitioning. So the first question is, can you see which virtual columns are there when you do describe on the data set, I guess? I don't think you can, right? Or can you?
If I recall correctly, no. But maybe I'm wrong, and there is a invisible setting like show virtual columns in describe.
Try out that setting. It might work.
Yeah, I recommend just to look at the file names at the path, and You will see these virtual columns.
And then second question, and I think the answer is no, but you can tell me if I'm wrong, does the Hive partitioning like pass down the predicate, or does it go through all the files and then filter them?
In the current release 24.8, as of today, these predicates are not pushed down. But this is
Okay.
something that we want to improve maybe tomorrow. So
Tomorrow.
maybe
Just
tomorrow.
just wait till tomorrow.
I asked my colleagues, like, can you please do it today? They answered, something is difficult, so I asked it to do it tomorrow. No
Okay.
problem. We will have it tomorrow. Okay.
So 24.9 will be there.
We will see.
Okay, another one. Hang on, let me see if I get this question. So what if there is a column name conflict between a Hive partition virtual column and a physical column in the data set? Okay, so we're saying like the folder structure contains some sort of name, which is also a column in the actual Parquet file.
We decided on this question just today, and we decided that virtual columns should take the preference. But there was another proposal, like to add leading underscore to the name of virtual columns, so they will be accessible anyway.
Okay, got another one. Now this is about projections. So what will happen with a projection if I remove a partition in the original table?
The projection will be also removed. Projections live inside data parts. When you remove data part, projection is also removed. Okay.
You know, I've never used a projection for something. I need to use it so I can understand what everybody is asking.
You should use projections. Okay, let's move on.
Now I got one more question for you.
I have 1 hour for this webinar, but okay.
It's about projections again. Will the new projection mode recreate respect the partitions of the main table?
Yes, it will respect partitioning, because every projection is partitioned in exactly the same way as the main table.
Cool.
Okay.
And then somebody has found that there is a setting called describe include virtual columns. So you can get back the virtual columns when you do describe. So thanks to Scott. Right, anyway, I will stop up talking now and hand back to you.
This is really nice. We have settings for every use case. Whatever you want, here is the setting. Okay, let's take a look at optimizations. The first one is optimization for subcolumns. What are subcolumns? So whenever there is a complex data type like array, tuple, or nullable, and complex data types can be also recursively nested, like array of array, array of tuple, etc. They are represented not by a single file or a single stream of data, but by multiple streams of data. For example, arrays are represented by their elements and the sizes of each array. And now we have an optimization that allows to read only subset of these streams. Actually, we used to have this optimization a long time ago, but it was not enabled for reasons. And for another reasons, it is enabled. So let me try to show it on one example. Again, I will copy paste some queries. And I will go to a server in ClickHouse Cloud containing the data about code coverage. First of all, let me look at the tables that we have. We have a table named coverage underscore log underscore something. It has not a lot, just about 100 million records, but the size of this table is 4.2 terabytes compressed and 30 terabytes uncompressed. Despite quite good compression ratio, 7.2.1, the table is unexpectedly large because it has 300 kilobytes on average for each record. Let's take a look what this table is. What does it contain? And it contains for each commit, for each pull request number, and each test, it contains code coverage. It is array of addresses and another array of function names, named symbols. And probably these arrays are large. Let me try to find how large these arrays are. We will just look at the total size. Interesting. How long this query will take. And it is slow. I don't like this query. I don't like this query, and I will have to change the password for this server. But let's take a look again. It starts working. 30 gigabytes per second, 35. And it processes just 400 gigabytes. And it will take quite some time before it will process all 30 terabytes. Now let me try to enable this optimization. Optimize functions to subcolumns equals to 1. Will it be faster? How faster? Mark, what do you think?
The other one, well, the other one never completed, so it's infinity faster. I don't know, 10 times faster.
Let's take a look. So far it is slow.
Well, 100 times faster, right?
The previous query was processing at the speed of 34 gigabytes per second. Now we have 30 megabytes per second. So how slow it is? But actually, the previous query processed 4 million records, and the new query already processed 76 million records. So it is faster. But nevertheless, I don't want to wait. Let's put it simple. It is faster. And this optimization is enabled by default in version 24.8. Another optimization. The optimized table query now is applicable for join tables. You probably know what join tables are. This is a way to optimize joins in your queries by creating prepared hash table in memory. You just create a join table, insert data into join table, it creates the state in memory, and when you join with the join table, your query is faster. The downside, it requires a lot of memory for processing. So in the new version, there is optimized table query, and it will just shrink down the memory usage for this table. So for example, before optimized query, some table took 257 gigabytes in memory. After optimized query, it took just 184 gigabytes. Quite a decent improvement with just a single command Another optimization, an optimization for merges. In the previous version, if you have a wide table with hundreds of columns, if not thousands, merge can take a long time just because it has to schedule processing of every unit of work, every chunk of data, like 1,000 or 8,000 of records was scheduled, and this scheduling takes some time. In the new version 24.8, it was optimized by batching. Classical optimization, absolutely trivial, and the outcome is that in many cases it is optimized 2 times from 26 seconds to 13 seconds. It is pretty nice. And even more optimizations. We have faster drop database. If you accidentally created too many tables, now you can drop these tables faster. Just to drop database, it will work in parallel. It will be quite fast. If you used to write data in ORC format, I don't know why, what is the case for ORC format instead of Parquet, but whatever. If you need to write ORC often, now it is 15% faster. And yet another optimization. This optimization for a certain disk type, and disks are the implementation of virtual file system for ClickHouse to allow using external storage such as S3, Azure, GCS with ClickHouse like a local storage. And there is a disk type named plain rewritable. And this disk type allows you to create a merge tree table that will be updated with inserts by a single replica, by a single server. And there could be infinite, unbounded number of readers to read this data. So with this plain rewritable disk, you can create something that looks like data lake, but not like iceberg, not like delta lake, but something like that is native for ClickHouse that uses merge tree tables. And in the new version, it was optimized using a better data layout. Let me show you some demo of this feature. I will again copy-paste a few examples. I will attach a table that is created independently by another server. So there is a server somewhere on the internet creating this table and updating it. And now I'm just an observer. I will attach this table. I have to specify UUID that I should know in advance for this table. I will specify the type of disk, S3 plain rewritable, and the endpoint. A bucket on S3, this is a public bucket, and it is created in 12 seconds. Let me try to use this table. It works. It is fast as typical merge tree. No problem. Let me create another table that was created on version 24.8. And we will see, is there any difference? So another table with another UUID, and it uses another bucket. And the difference is clear. 3 seconds to create a table on the new version, and 12 seconds on the previous version. Let's try to run a query. And the query is also faster. I don't know why, but it is faster. 1 second and half a second. Maybe it's just a coincidence.
Wait, did you run the you ran the query on the first table, didn't you? Shouldn't have been hack and use history 2?
Ah, so it was a coincidence. Nice catch. It is not faster.
About
Now
the
it
same,
is
isn't it?
faster. Okay. Let's just for comparison, I will run a few times on the previous table. And queries run at the same time. Only creating this table was faster. Okay, let's do yet another query just to show that this table is updated in real time. Let's take a look at top stories for today. Interesting. Maybe I should read these stories. Transformers for Ruby. No, I don't like Ruby. Let's move on. Okay, let's take a look at something interesting, something unusual. And the first item is analyzer in production. Most of you already know what is analyzer, but who does not? Let me explain. Analyzer is a new infrastructure for query analysis, for query optimization. So it enables complex queries in ClickHouse that were not possible before. With analyzer, this query worked. Without analyzer, they did not. And we have analyzer from almost 2 years. Since version 22.10, it was introduced in the experimental status. After almost 2 years, it went in beta status since the previous LTS release 24.3. And in the new version 24.8, it is finally in production stage. We are confident about using analyzer in production. It is battle tested. It has been enabled in ClickHouse Cloud for all new services by default, and it works perfectly. So now we are confident about this new infrastructure. Let's take a look at some new features that are experimental and introduced just now. The new Kafka engine. So you know that ClickHouse can read and consume data from Kafka directly. The Kafka engine existed since 2017. And it is easy to use. You create a Kafka table, you create a materialized view, and it consumes data from Kafka and possibly processes this data with some expressions, with some data pipelines, possibly aggregates this data, parses this data, etc. But this table engine has one downside. The problem is that when it inserts into the destination table like merge tree, it commits the consumed offset into Kafka and inserts into the table. And this is not atomic. And it is possible to get duplicates in the case of retries, in the case of network errors, server failures, rebalancing of partitions inside Kafka. And it is quite annoying. You don't want duplicates in your tables. Now this problem is solved. It is possible to not use Kafka to manage offsets. Instead, we will consume data from Kafka, but not tell Kafka that we consumed this data. We will manage offsets on our own in ClickHouse Keeper. And as we do everything by ourselves, it allows to control this process precisely. So how to use it? First of all, enable unlock this table engine because it is currently experimental. Then you create a Kafka table as usual, but with two additional settings. A path in the keeper or keeper and the replica identifier. And it will work like this. It will store offsets in keeper. It will also store intentions about what exactly, which chunk of data we intend to consume from each partition in Kafka. And in case of any network interruptions, connection losses, server failures, and even rebalancing of Kafka, we will repeat exactly the same insert with exactly the same chunk of data. And the deduplication mechanism makes this insertion exactly once. So now we consume data from Kafka and insert without duplicates, without data gaps, 100% consistently. This table engine is continued to be developed. For example, direct select queries are still something we have to do, but it is ready for preview. Yet another experimental feature, even more interesting, even nicer. Time series table engine. And with time series table engine, ClickHouse supports Prometheus protocol for remote reads and remote writes. So you can take ClickHouse and tell Prometheus that it will write everything into ClickHouse, all the metrics. And on ClickHouse side, it is easy to use. Again, unlock this feature because it's still experimental. It is not for production, but okay if you want to experiment. Create a table with engine time series, and you don't even have to specify the table structure. Everything is automatic. You can override table engines for individual subtables. The time series table engine actually creates 3 more tables under the hood. The table for data, for metrics, the table for tags dictionary, and metric names dictionary. And to configure it, you enable Posus Handler on a specified port with a remote write endpoint like this, remote read endpoint, and possibly another endpoint to expose server metrics. But it is what we already provide. These 2 endpoints are new. Then when Prometheus will write data to this remote write endpoint, it will magically appear inside this table. When Prometheus will do a query, it will go to this endpoint, and ClickHouse will interpret it to query this table. So now ClickHouse listening to Prometheus protocol, and it will receive the metrics. You can apply some customizations for this table. For example, it is reasonable to extract some tags like host name, like maybe client name, into separate columns. And then you can also override the table primary key for metrics, so it will serve select queries efficiently. You can adjust column types, you can adjust a lot of details. There is a lot of things we want to improve for this table, like we want to implement full support for PromQL. Currently, Prometheus will just extract raw data the values of metrics and interpret PromQL on its own. But it is suboptimal. We want to do it better. So pretty nice. I advise you to try, experiment, test, and tell the results. Okay, yet another interesting feature. A new JSON data type. This new JSON data type is a replacement for the old object data type that did not prove itself in production. And the new JSON data type is intended to solve the problems that we used to have. So how it works? You create a table and you specify a column with type JSON. That easy. You can specify it simple without any parameters. You can specify some parameters like limits to the number of paths, unique paths in your objects. But don't worry, even if the number of paths is more than that, it will fall back to a different representation. It will support any JSON that you will send to it. You can specify to skip some columns just not to waste storage for them. You can specify hints for data types, so it will help with type inference. But don't worry, you can just write data JSON without any parameters. And how it works? When you send a JSON, it will analyze it. It will check every path, every unique path, and infer the most suitable data type for each value. Will it be an integer, floating point value, date or date time, string, array, nested object, nested array of objects, everything. Everything that JSON could have is supported. And every path will be stored as a separate subcolumn. And if a path used to have different types, like sometimes strings, sometimes integers, it is also supported. It will be represented as a dynamic data type containing subcolumns for integers and subcolumn for string. And if the number of different data types is too large, it will transparently fall back to slightly less efficient representation. We will just store the rest of the paths together. I see someone raised a hand. If it is a quick question, maybe I can answer, but let me continue. So you can use ClickHouse for semi-structured data. And this semi-structured data will be stored as efficient as fully structured data. It will be stored in a column-oriented compressed format, as usual. Let's take a look how to insert data. You can insert in JSON each row format. Then you have something like this. If you have a column data JSON, it will be just a sub-object in the JSON each row format. You can insert a string containing JSON, and it will be automatically cast into the JSON type. Like in this example, you insert values with a string containing JSON. You can use the format named JSON as object, and it will interpret all the object as a single JSON field. And you can use the cast operator and use insert select to cast any string into JSON, assuming the JSON is valid. What can you do on select queries? First of all, you can use this quite easy dot notation to extract the dynamic column. Actually, let me walk through these examples. I will create a table and I will show it to you. We will create a table like here. First of all, we have to unblock this feature. It is still experimental. Okay, the table is created. And we will insert just a single record. Mark, what do you like? This insert or this insert?
I think I like the second one.
Yeah, it's like more natural.
I have a question for you. What happens to the old JSON type? Is it just deleted and replaced by this? Is that how it works?
First of all, it will be available under deprecated flag. Then it will remain for like half a year, and then we will just remove it.
But does it have like a slightly different name? Like I thought it was called JSON as well, or was it something else?
No. If you unlock the old JSON data type using the setting allow experimental object type, it will be available under the same name, but you should not.
Oh, clever. Okay, got it.
Yeah, but also it is available under a complex name, object of JSON. Okay, forget about the previous data type, it is not interesting. The new data type is so interesting. Okay, the data is inserted. And let me try to do something. First of all, let me read this JSON back. Yeah, here it is. It has the type JSON. Now let me extract the value. It is 42, and the type is dynamic. I can also analyze the internal type using this function. And the internal type is int64. I can do explicit cast. So let's imagine that sometimes it is integer, sometimes it is string, sometimes it is float, but I still want to process it. And I can do something like this. And it also works. It like schema on demand. And there is another interesting operator that is similar to the cast operator, but looks like this, dot, colon. And if I use it, it is a type selection operator. It will extract the values when they are exactly of this type. And we did not have any value of type string for this subcolumn, so it shows null. But if I use it for the actual data type int64, it will extract the value. And it is, I think, the most optimal way to use subcolumns. Also, there is one interesting thing. If I will extract an incomplete path, so it is an object, it will show that the value does not exist. Because it is not immediate value, it is just another object. But there is a special operator to extract this subobject as a JSON data type. And it will look like this. It works. Okay. And let me show you something more, a little bit more sophisticated. Let's test it. Let's do a battle test for this new JSON data type. So we have some data set. Let me analyze this data set from S3. It contains a JSON, and this JSON is so large and complex that it was not even displayed in this format. I can actually show it to you. So here it is. Typical JSON, as it used to be. What can we do with this data? Let me create 3 different tables. So in the first table, I will not use the JSON data type, but I will use a mechanism of schema inference. It will automatically create the table structure and columns accordingly to this JSON. The downside is that you cannot change this schema afterwards. It will be fixed on creation. Okay, 13 seconds. It has read this file. It inserted 200,000 records, not many, but still. Let's take a look at this table. Yeah, it automatically inserts this structure. You would never create this table manually. It is only suitable for schema inference, because let's imagine if you will have to type this. Okay, let's create another table using our new shiny data type, JSON. In this example, I will put everything into a single column of type JSON. And I will use the JSON as object format. That literally means take all JSON as an object. Okay, it works, but will it be faster? Will it be slower? No, the same 13 seconds. Probably just reading this file from the network and the decompression is slow. Okay, the table is created, and now it is opaque. It is just a single column of type JSON. And just for comparison, I will create a third table. And instead of JSON, it will use a string data type. And I will say it is a classic way for processing JSON. Just put everything into a string. It should be faster, yes, and it is faster. Only 2 seconds. Now let's use these tables. I will see how many interactions with GitHub I did at 10 o'clock UTC today. 2 interactions. Let's verify it works. And it is fast. It is actually instant. Let's take a look at something more interesting. Let me look at this JSON. And this is my event on GitHub, what I did, everything about myself, everything about our precious repository, about programming language. I can use this data and do something interesting like this. What I commented today on JSON. Oh, sorry. What I commented on GitHub. Mark, what do you think? Was my comment insulting, offensive, or just polite as usual?
Yeah, I expect it was very polite.
I also expect that, but we will see.
Here we go.
Is it polite?
Well, it's null.
So I did 2 events. In one event, I left a comment, this comment. And in the second event, it was probably not a comment, so it was definitely polite. But probably null is not is impolite? I don't know. But I used just the table with schema inference. Actually, let me try to use the new JSON data type. So we have a JSON column, and I use the usual dot notation to get this data. The query looks almost the same, and it is actually faster. Huh. It is faster. I don't know why, but it is. It is magic. And just for comparison, I will show you this query from a table with strings. And the SQL standard contains a substandard named SQL JSON. And we implement this. I would not say substandard. We implement this standard in a standard way. It looks a little bit more hairy with this function, but still similar. And it is slower. It is not 10 milliseconds. It is 300 milliseconds, but the result is the same. And we can also introspect our JSON column using this function, and it will show all the path I can get from inside. Okay, what else? What do we have as a bonus? We have a new service named CryptoHouse. CryptoHouse is a free data analytics service located at crypto.clickhouse.com, created by ClickHouse Inc. together with Gold Sky, where you can analyze all the Solana blockchain. It is hundreds of terabytes, but it is not a problem because we use ClickHouse Cloud. And what is hundreds terabytes? Hundreds terabytes are nothing. Okay. Another interesting news is about CHDB. So we tested the performance of CHDB in comparison with other embedded query engines like Pandas, Polars, DuckDB. And unsurprisingly, CHDB is the fastest. DuckDB comes quite close. It is trying to pretend to be similar to ClickHouse, but does not really succeed in this matter. But it is slower, but still quite okay. Pandas is the slowest, is really slow, but fortunately, it is being able to process all the queries, just slowly. And there is Polars. Polars is written in Rust, and it is slow, and it is also crashing on some queries. I don't know why, but it is crashing. So CHDB is the best. Some news about ClickHouse integrations, for example. Now we support continuous insertion from S3 in Click pipes. We support JSON inside Kafka, schema identifiers inside messages in our Kafka connector. And what about the Rust programming language? It is not only slow and crashing, actually, it is a good programming language. And the driver for Rust is now official. About meetups, there are so many meetups in the United States, in Hong Kong, in Australia, in mainland China, in Canada, Netherlands. And probably I will be on some of these meetups. I will not tell on which ones, but you should visit if you are in one of these cities. And there are many interesting updates in our blog. For example, if you want to use free credits in AWS, good news, ClickHouse now is a member of AWS Activate program. And if you use ClickHouse, you will probably get, I don't know the exact conditions, probably you will get free credits, free training, free support, everything for you if you use ClickHouse. If you use ClickHouse for machine learning and AI, there are a lot of materials from cognitive. If you use ClickHouse for not AI, but for games, there is a nice story from Azure Games. They migrated over 100 terabytes, and it was an easy, smooth migration. And there is a story about PeerDB, our new engine for continuous replication from Postgres. There is a lot of interesting stuff. And now we have -7 minutes for questions.
Good job by us. Finishing on time. The only question we have that we haven't answered is what happens if you were using the old JSON type and now you want to use the new JSON type? Is there a way to switch from one to the other one?
Yeah, absolutely. So you can enable the new JSON data type, and the old tables will continue working because in the create table statement, these data types are different. The new JSON data type is named JSON, just JSON. The old data type is named object. If you create a table with the JSON as the data type name, the behavior depends on whether you enabled the new JSON data type or the old JSON data type at runtime at this moment. If you did not enable any of them, it will just tell you that you have to enable either one experimental setting or another experimental setting. If you enable the old JSON data type, it will create a table with the object data type. If you enable the new JSON data type, you will use the new JSON type. So everything is perfect. The only consideration is that after a year or after half a year, we will remove the old JSON data type, but still you will be able to migrate, just dump the data and load it back, and problem solved.
Okay, cool. Next question is, are you going to optimize CTEs? Now, I assume this means the problem is that if you use a CTE multiple times in the same query, it executes it each time. I'm guessing that's what they mean.
I would say we very much want to do it.
Okay. We're on it, Sergi. Okay, next one. Are you aware of a scalability issue with the thread pool? It seems that ClickHouse can stall when ClickHouse creates a lot of threads to execute queries. I don't know if you're going to be able to answer that one live. Do you know about that one?
Yeah, this is quite interesting scenario, and it depends not only on ClickHouse, but also on the Linux kernel version that is different by default in different cloud providers. We used to find one interesting issue with GCP and their Kubernetes service, which by default used to have the version of Linux kernel that was affected by a possibility of lockup for a long time under certain conditions of memory usage. So when you have some scalability issues, ClickHouse is not always to blame. But my advice is just to create a service in ClickHouse Cloud and this problem will be solved not by you, but by us.
Cool. We've also got someone who says, thanks for the new Kafka Engine and Analyzer. And then there is one more question. It's kind of like zooming back to when you loaded the table with the data on S3. And the question is, I mean, I guess there's kind of two parts to the question. So I guess well, the question is, why did you need to specify a UID at the top? And then I guess the second part of that question is, how did you know what the UID would be?
Let me first answer for the second part of this question. So I created this table on my writer server, and then I just considered the system tables, and it contains the table UID. So it is easy to get this UID. Now the question is, why do I have to specify it? Because I can create a table under whatever name I would like to choose. So the writer server will have this table under the name Hacker News History. And on my readers servers, I can create a table with the name whatever, test, a table, whatever I like. Mm-hmm. And ID is just a unique identifier that we have to find this table.
Got it. And how did you, like, third part to it, how did you upload the table? Did you just copy the directory and or zip it up and put it in S3, or how do you do that bit?
It happens automatically. So I create the same disk, plain rewritable, on my writer server. And I insert data into this table, and it is auto inserted to S3. I don't copy anything manually.
Oh, okay.
For itself, by itself.
Nice. Cool. I didn't know you can do that. That's quite a cool feature. And that, I think, is all the questions. So I guess we'll wrap up. Sorry, we're a bit late, but thanks to all of you for sticking around so long. If you're in Europe, have a good evening. Everywhere else, I guess somehow you're in Australia, have a good day. And everywhere else, I guess, yeah, have a good day as well. And we'll see you, I guess, end of September.
Thank you for listening.